So we added the IDB file. We're using it in index.html, but of course, as you know, the service worker works independent of that page. So how can we use that package in the service worker? The answer is, by default, we can't, because the service worker doesn't care about which polyfills or packages we load in our main project. But service workers have a special syntax which allow us to import our packages. And that special syntax is import scripts. This simply allows us to point to another script which we want to use in that service worker. And this in general allows you to distribute your code across multiple files. You can of course also use this to make your service worker leaner and outsource some of the code into a separate file. Though I prefer to keep everything in here to have one place where I can quickly see where I'm handling fetch events and so on. Though you could of course also argue for outsourcing this. Nonetheless, what I will do here is I will import that IDB file. So I'll import to source JavaScript idb.js. Now, of course, it would be nice if that also works if we're offline. So for that, I'll also import it into my static files cache. Here, I'll also store idb.js, just as I store promise and fetch, to make sure that we can use all that functionality even without an internet connection. And for that, I'll bump up my cache version number here. So this imports idb.js, and now we can use these features in our service worker file. Now to do so, I'll start by simply storing data when we get it from the database. And do you know where we would do this in our existing service worker file? Well, we can already see it in the picture here. Here. Right now we put something on the cache, on the application cache, whenever we get data from the post URL. Now, I told you that for JSON data, we might prefer IndexedDB, because there we can really decide or define what we want to store there. So this is what I want to do. Instead of putting something on the cache here, I want to put something or store something in IndexedDB. So let's do that. For that, we first of all need to open an IndexedDB database and also create an object store in there. So I will do this at the top of this file, maybe after initializing my static files, and I'll store the database, which can be accessed through a promise, in a variable named dbPromise. So this will be a variable which in the end can give us access to the database in a promise-like way. You'll see how it works. Here, I'll set this equal to IDB, which we can now use due to this import being added. IDB open, and this opens a new database. Here, I want to give it a name, like feed store, because it's for my newsfeed. You could also name it post store. Let's maybe name it like this now that I think about it, because we use posts in Firebase too. So post store. We can pass more arguments, the version number of the database, which we can simply bump up if we wanted, if we update it. And then we get back a function. Now I told you it's promise-based, but this one function can't be avoided. This function will execute whenever the database has been created. And there we get back an object which allows us to access the database basically. Now here I want to create a new object store, which is basically like a table. To create one, I call db create object store. Now we can set up this function with two arguments if we want to. The first one is the name of that store, and I will simply name that posts. So we got the database, and now we got the table in there, the object store. We can also pass a second argument to that to define an object where we define our primary key of each object we'll store in that object store. This allows us to later retrieve objects by that key. So we simply have to define a property named keyPath here, uppercase P, and you have to get that name right for IDB to understand it. And then the value is a string where you define the name of the key by which you later want to retrieve your data. I'll name this ID. So if I later add objects to the object store, which have an ID property, I can conveniently search for objects with a given ID if I want to retrieve a single object. That's the good thing about providing this extra argument here. This creates a new object store. The issue just is, we'll use this promise here whenever we want to access the database. And there we open the database. Thus far, that's no issue. But we always also try to create that object store. We only want to do that if it doesn't exist yet. And unfortunately, IndexedDB and this package doesn't do that for us. It's not like in the cache where we open a cache and it either creates it or simply opens it. Here it always tries to create it, and that of course is not a good idea if we already have it. So therefore I'll wrap this in an if statement where I check if we don't have this yet. So if we don't have it in our given DB here. I can do this by checking object store names. This will simply give me an array of all the existing object stores. And I can check if that contains the posts store or object store. And only if that's not the case, hence the exclamation mark at the beginning, I try to create it. So this creates a new object store, and with this promise I can access this database with this object store. So let's get rid of our old code here. And actually we don't need to open the cache anymore. Just returning the fetch is all we need to do here. So let's get rid of that code too. Whoops, that was too much, just delete that. And now with that, we're making sure that whenever we hit this URL, we respond with the fetch. And in this case, we just return the response. Now, of course, I want to do a little bit more than just that. Instead, I want to store that response, or actually transformed response, also in IndexedDB. Now, to do that, I first of all need to create a copy of the response. I'll store it in a new, maybe cloned res variable, and I call clone on response here, because the original response of course always needs to be returned, even if I store the other one, because otherwise our fetch requests from our main application will fail. So here I'm returning a cloned response, or excuse me, I'm returning the original response, but I'm cloning it too, and I want to store the transformed cloned response. Transformed because that's the good thing about IndexedDB, we don't have to stick to the full response. We can pull out the data we want to store and store just that data in the database. So we have the cloned response. On the cloned response, I now want to call JSON. This normal JSON method, which of course gives us back a promise, as we can confirm in the feed.js file, where we return response JSON and then chain another then call. That's of course possible because this also returns a promise. So here we know it gives us a promise, so we can call then, and you can therefore use the data we got back from the response. This is now the body data, but still not transformed at all. Regarding the transformation, we can have a look at the feed.js file again. It's this transformation I want to apply. Pull out the key value pairs from the data we get back from Firebase, because we don't get back an array of posts, we get back an object where the keys are the post IDs. That's just how the data is stored in Firebase. So I'll copy that loop here into my service worker, and I'll get rid of the data array push thing in the middle, but I want to loop through all the keys in my data. So through all the posts in the end. Keys, of course, is just the identifier of the post though. So with that, we got the data transformed. Now, of course, I also want to store it in the database. And for that, we use the DB promise we set up here at the top. This gives us access to the database through a promise interface. So we can call then. And inside of this then block in the function here, we get access to the opened database and to all the object storages we set up in this promise. So in this case, only to the post storage, but if we had more, we could access them all on this DB object we have here. Now I want to use that DB object to write some data to the database. And for that, I first of all need to create a transaction which I'll store in the tx variable. I told you that IndexedDB has this transactional operation model. So basically we have to use transactions for everything we do with the database. A transaction is easily created by using the DB object we get in this function and calling the transaction method. Now this method takes two arguments. The first argument decides which store do we want to target with the transaction. Now we only have one, the posts object store, this one, but if we had more, we could of course decide which one to use. The second argument decides which kind of transaction is it. Now here you have a couple of options. The most important ones are read-write or read-only. Here it's clearly read-write, one word, don't mistype, because we want to write something to the database. Reading alone doesn't suffice. Next we have a store, which we have to open. We do this via the transaction and the object store method. Now it might look strange because we already defined a store here, but that's just how IndexedDB works. Here we basically say what we want to target with the transaction. Then we explicitly have to open the store. Now that we got access to the open store, we can use that and put something. Put is one of the methods you can execute on the store, and throughout the module, you'll learn about a lot of other methods you can use, like get and so on. So here's put, and of course I want to put my data. Not the complete data though, but data key, which, just to bring this back in memory, is simply this object here. So the value of this key value entry here, that's data key. That's the key. That's our data, all the different keys if we had more, and therefore data key is just a stored value. This is what I want to store in the database with put. Now, the good thing is, in that object we store, we have an ID property here. This ID element property we stored in that object. And I defined that ID would be my key path. So we can easily extract values later if we want to target single values by just pointing to ID because it's set up as the primary key here for posts. So with that, we put that data and we have that ID which is required. And now we can close the transaction by returning tx complete. It's not a method, it's just a property. And this simply makes sure that this transaction gets executed, that the put operation gets done, and we have to use a transaction even if we only have one operation like we do have here. And with that, we're executing this for every item in this loop, and we safely store the data in the database with that. So now with this stored and of course our transaction completed and the original request still returned, that's important so that our app still works. Let's see if it works. So let's go back to the application and let's clear the site data as always. Now of course as always you could also reload the page, close the tab and reopen it. I just want to make sure that the cache is cleaned though, because we made some significant changes to that. So let's reload the application now. And with that reloaded, it still loads here. Now, in our application tab, if we reload or refresh IndexedDB, we should see that there is a post store database with a posts object store, which is empty though. That makes sense because our service worker was just installed and doesn't manage this page yet. If we reload one more time though, we should see that now in the application here, if we refresh that, we now have that key value stored here in posts. So we have our first post ID, which is simply extracted from there and was used as a key because we set up the key path to be ID. And that we now have the object on the right, exactly the object we got from our Firebase database. Now in the console, if we reload one more time, we also see that on the next call, of course, it's not getting it from the cache because we only wrote the logic to put it there, but not the logic to get it from there. So this is what I'll do next.